Testing, testing. Testing.
Hello. Oh.
All right. You ready?
All righty.
Hello, hello, hello. Who's ready to learn about space?
Weak.
Oh, that was pretty weak, yeah. Who's here to learn about space? One more time so they can hear us at all the Astronomy on Taps out there. Who here is ready to learn about space?
There we go. That's better.
Awesome. Welcome, everybody. So we're excited to see so many people here. I'm sorry it's a little bit crowded. At least we get a little bit of fresh air. So welcome back to those of you who have been here before. You know what I'm about to do. Who here is brand new to Astronomy on Tap? Raise your hands. All right. Welcome, everybody. Let's do a quick cheers to the newbies. Welcome. Yeah, so what you're going to hear about next is a little bit about what Astronomy on Tap is. We've been here in San Antonio since 2017. You can actually see that this is number 32 for us. And in fact, next month will be 1 year since we came back live in person. So come back next month and check out our special event for that. Go ahead, Michael, take it away.
All right. So what is Astronomy on Tap? I like to say, that's Tracy Becker. I'm Michael Velez. Aaron DeLeon, Sam Hart, Adam Bark, Brian Beck, and Thomas Lechner at home on the stream. That's our team. And what is Astronomy on Tap? I like to say it's a worldwide phenomenon. And it started almost 10 years to the day in Brooklyn, New York. So they're having their anniversary this week. So cheers to them and to Astronomy on Tap. They gave us a wonderful event to have. So so that's a little bit about, in general, here in San Antonio, we love to have fun and keep it interesting and interactive. And you get a chance to win prizes at the end with our trivia. And we guarantee all of these. So no money back, sorry. No. But also feel free to follow us on our socials because that's where we put every month. We'll advertise our events, so you'll be able to keep in touch with us. And sometimes we'll put cool pictures there. We'll retweet NASA stuff and any interesting thing that's happened. So follow us on our socials. And here's tonight's schedule.
All right. Today we have two excellent speakers. I'll let you decide which is which. And our first speaker will be Dr. Kurt Retherford, talking about space policy brought down to Earth. Very excited for that. We will then have a quick break to get refills, and UTSA Astronomy Club's Caleb Gamar will give us Astronomy in the News. Looking forward to that. And then finally, we will have Ange. How do you pronounce your last name? Last name. Pontoni? Okay. Angel Pontoni talking about the upcoming JUICE mission launching soon. So, without further ado.
All right. Tonight's first speaker is my PhD advisor, Dr. Kurt Retherford. He is currently a staff scientist at SWIRI. He received his bachelor's degree from Wisconsin-Madison and his PhD from Johns Hopkins in physics and astronomy. Since then, he has donned many hats, as I've been told. He's an adjunct professor at UTSA. He has led roles for instruments on the Lunar Reconnaissance Orbiter for the Moon, Europa Clipper, and JUICE, soon to be in orbit near Jupiter. Furthermore, he's an active contributor on the European Space Agency's Mars Express SpyCam investigation, and he participates in a Mars Scout mission concept study. Finally, he's intimately involved with several projects regarding the Hubble Space Telescope, as I know. To summarize, Kurt's many hats have made him the perfect person to discuss the logistics of managing and producing scientific instruments funded by you, the taxpayer. We thank you. Thank you very much. You keep us alive. Without further ado, Dr. Kurt Retherford. We have first-timers in the room, so a little tradition of ours is we have a drinking word. And basically, when Kurt will say a certain word, you all will say, woo, and take a drink. So what is your word?
Mystery word of the day is space. Space.
Oh boy. Uh-oh. Uh-oh. Woo responsibly, everyone. All right.
I need the remote.
Oh, yes. The remote. There you go. Down for forward. Yeah.
Okay, welcome. Thanks for showing up. We're going to talk not so much about something in the solar system, but how we pay for everything that we do here. So we all are very grateful for the taxpayer funding that does go into supporting our space science. Woo! We got it. All right. And so being citizens in our country, it's really good to know how the government works, how this process works. And what I want to do tonight is empower you all to help us out with the funding that we get. At the end of the talk here, I'll give instructions on how to actually contact your congressperson and follow up with them and say, hey, space is great. Woo! All right. All right, so some of you are like, oh man, I came here to learn about science and fun stuff and see some great images. Politics, ooh, boo. Politics is bad. No. Not as bad as Microsoft, maybe. I'm just going to say the word space and take a bit drink myself. All right, 1, 2, 3, there we go. So a lot of people think of politics as being backstabbing, in it for myself. How do I throw people under the bus? How do I lie and get away with things? But that's not how I view it. I'm much more of a cup is half full, not a cup is half empty type person. And so in my mind, politics is how we get together to get stuff done. How do we find those win-win situations? How do we work together as a community to make the world a better place? And so that's my view of what politics is. And at the end of the talk, I hope you all share that more with me. All right, Congressional Hill visits. So in addition to all the hats that Michael nicely mentioned, and yeah, as a grad student, it is really good to suck up to your advisor. So yeah, thanks for listing all of those. But one thing that I've been involved in is in our professional society, leading our federal relations subcommittee in terms of advocating for NASA funding, NSF funding on the Hill, and taking people around to, with other scientists around to go talk to Congress people, Congress staffers, and explain to them just what it is that we do and why NASA funding is really important. You all know the bottom line from all the great results that we share at Astronomy on Tap, right? Lots of good space science results. Woo. So I don't do all this by myself, but for about 6 years or so, I did lead this subcommittee. And then more recently, I handed it on to Angela in the middle of that photo up there on the left. And what we do is go through different congressional offices, meet with staffers, like I said, but then also we'll talk with other folks at NASA headquarters. And this is a photo of me at NASA headquarters just last week in front of not an astronaut like one of my Tinder dates asked me, is that an astronaut you took a photo with? But no, it's really a mannequin in a spacesuit here in the lobby at NASA headquarters. And the cherry blossoms in DC are blooming right now, and it's pretty amazing, including this cherry blossom right in front of NASA headquarters. So when I do talk to these congressional people, I really emphasize that NASA is in the inspiration business. A lot of the things that we do at NASA really inspires folks to get into the STEM field in general. And that is a huge driver for lots of things in our economy, as you all know. All right, live action shot. So the next few slides, just bear with me. This is a little bit of a civics 101 in terms of how bills get passed, how funding gets appropriated in Congress, and what that process is all about. And the more that you know about just the nuts and bolts of how this works will benefit you in any kind of advocacy that you you do going forward in terms of even just having an opinion on how things get funded with your taxpayer dollars. So on the left-hand side is the executive branch. Things start with the folks at the White House giving broad stroke guidelines to folks at the leaders of NASA, leaders of National Institute of Health, NIH, leaders of National Science Foundation, NSF, and the folks at these agencies will come up with a detailed budget for the next few years in a row and pass that back to the White House for a review in the OMB and OSTP, which I'll talk about in the next slide. And the president makes a suggestion for what the budget is, but the Congress really implements the budget and approves it. So it's a back and forth process, a little convoluted. It gets really confusing and you think that everything's dysfunctional. But when you actually do meet with these staffers, you realize that there is a method to the madness and that it actually does have a really good system for understanding just where all of those taxpayer dollars go in the end, by and large. So after the executive branch gets the agency inputs, people at the offices of management and budget will review these things. I guess I want to talk to the next slide here. OMB is Office of Management and Budget. So they'll go through with a fine-tooth comb what those budget numbers are for Europa Clipper or science research and development, and they'll say, are these things really getting the best investment for our dollar? Are we spending too much on this? Are we not spending enough for what we're really needing to deliver? And there is this back and forth within the executive branch before budget numbers go on to the next step. The Office of Science and Tech Policy is more of an overarching type of advisory part of the government that'll say, hey, we really should look more into building computer chips because, oh my gosh, to be competitive, we need to focus more on this. So they'll be the ones that have more of the overarching initiative saying, hey, we need to be putting so much of the federal budget into such a thing or not to make sure that the country can really achieve all of its goals across the board. So finally, after all these groups within the executive branch come up with their numbers, they come up with what's called the President's Budget Request, PBR for short. And that hits the street in the so-called Capitol Hill lingo. And that just hit the street just a couple weeks ago. And you might have seen some press releases about federal spending and the budget process. And in a lot of ways, that's sort of a Kickstarter for other folks to get involved on the congressional side of things, on the right half here of the drawing. Let's talk a little bit about these budget committees. So in Congress, there's an overarching budget number that folks want to come up to, whether we're going to bust the deficit or not, in terms of where these numbers comes in, is what these folks in Congress will draw a line on at the top level. And then those numbers will flow down to different committees, which flow down to different subcommittees. And so there'll be a committee on commerce, justice, and science that then has a subcommittee on just space. And so, whew, exactly. You guys are awake, yes, like that. All right, I haven't put you to sleep yet like my talk here is supposed to do, right? So there is this method to the madness. These numbers do get into the appropriations committees. There's another authorization line of authority that says, yes, we do authorize you to appropriate this amount of money. The Congress people have kind of ignored the authorization folks in a lot of ways when it comes to the actual numbers that get passed in the final appropriations. But the authorization folks will also say, we really need to put more funds into this or that and have a more strategic view on that authorization side of things. Let's talk about, on the next slide. So at the end of this whole process where people in Congress go back and forth, talking about the space budget. There'll be 12 different sort of bills across the whole of government. The one that includes NASA is just one of those. And Usually a lot of these bills get wrapped up in what's called an omnibus, just so that it's politically palatable for everybody to sign on and vote for it, where nobody loves what's in it in the end and nobody hates it all that much either. That's kind of the art of compromise. And like I said, it's a glass half full view of how this works, even if folks want to kind of tear that down. So that'll get sent off and then turned into a president's signature cycle. Within this fuzzy cloud here with the Appropriations Committee and subcommittees, there's a lot more that kind of goes on where there'll be inputs from different stakeholders, stakeholders like our professional society folks and myself going and saying, hey, we really should put more funds into this or that. And that's where different legislator requests flow into that process of setting a budget line. So when we go and visit these staffers, when we go and say, hey, this needs to be a priority for our country, this is the process where all of these things get pulled into those budget numbers that get passed in. And there's an iterative process, and there's a markup, is what it's called. And then it goes on to a vote by the subcommittee that just deals with space. Yes, nailed it. And then once that passes, it goes on to a full committee vote for commerce, justice, and science, for example, and all these different priorities for the government needs to be weighed in terms of Justice Department funding police and that sort of thing versus all the science that gets done and other Commerce Department relevant things. All those things get decided on and all these numbers get worked out, and then it moves to a floor vote when that full committee has everything lined up. And that's the key thing to really pass into budget. In this process here on the left end works basically the same for the House and the Senate side. So they'll both have separate House votes and Senate votes, and then they have to go into like a reconciliation period where they compare their numbers one at a time and really work out the final process, their final numbers. And there's all sorts of chances for amendments and line items and pork belly fat to enter into the flow of things. As you can see with those other arrows. All right, so thanks for bearing with me and getting a little bit educated on the Civics 101. It's really interesting how many times congressional staffers will hear from people saying, I want this, I want that, and they have zero understanding of what I just said here. So what I just said here is not rocket science. And so when a rocket scientist comes in and has no understanding of what they do day to day, their request, their ask for what they want them to be done really falls flat. So the more empowered you are with this knowledge of how that works, the better. So thanks for sitting through that. Now we're going to jump ahead a little bit, a trivia question here. And I'm going to go through, and I'm going to say our magic word of the day after each of these. And everyone's going to drink and say, "Hooray!" When I say, how much do you think we spend on NASA each year as a percent of the federal budget? Okay. A, 5% space. Okay. Those that think it's B, 2.5% space. You can say you woo all you like. How about C, 1% space? And D, 0.3%. Okay, so it seems loudest for everyone got it right. So we're a pretty well-educated crowd here. But national polls almost always come in and say NASA's funding is far more than this 0.3%. Usually the averages come in that 2.5%, maybe 5% is a little too high, but most polls, the guy on the street kind of poll will come in and say NASA's really funded at a much higher level than it is. And I think that really comes back to what I said about NASA being in the inspiration business, where people just think that NASA is really core to everything that's done on the federal level with science. And yeah, so here's another breakdown of where all the rest of that 99.7% goes. A lot of this in blue is what we call mandatory spending. This includes Social Security, Medicaid, Medicare, these sorts of things, interest on the debt. And then what's left in pink is what's called discretionary funding, and that's defense, a little bit of science there, and other programs just for our purposes. And the House leadership right now is looking to cut the discretionary spending drastically, which would include NASA. The Senate, fortunately, has its own say on that process, and so it's not all doom and gloom, but there will be really interesting budget discussions this year. Put another way, if we talk not just about NASA, but what our country invests in terms of research and development, what is that seed corn that we use to create those new ideas that drive the economy in all sorts of other areas? This excludes like operations cost. Like once you've built a rocket once and prototyped it, this does not include like building the rocket the second time, for example. And just for reference, space comes in at just 0.05% of total research and development when defined more narrowly that way. Another perspective on relative funding in the federal government. Here's NASA in orange, NSF in light blue, and Department of Defense is the big one in blue by factor of several, which may or may not surprise you. But I'm also happy to see that our friends at NIH have a pretty healthy funding in R&D as well, and rightly so. So just to give you a feel for how the federal breakdown is for NASA and other stuff related to space. All right. So like I said, the president's budget requests came out, and here's the latest and greatest numbers for NASA in that FY24 request column. There's a pretty good increase. Keeping track with inflation is the request relative to last year, FY23, which was even more than the year before. And NASA's top line there of 27.185 is a record high and a pretty good budget. But again, the House and the Senate need to agree with this president's budget request. And that's really our goal for science advocacy this year, is to, keep these numbers healthy. You can see in a relative sense, human exploration, that's astronauts and human exploration, is increasing in funding. That includes the Artemis mission. I think Caleb will talk more about that in the break. And space operations includes, boom, yeah, nice. That includes like the launch sites, running the space station day to day, operating things that are already working, and so on. Space technology, boom. It involves a lot of prototyping of things, so that's included in the R&D line in a lot of ways, and so on. So you get a feel for what NASA breakdown is on the top level. All the great results we bring you here at Astronomy on Tap are really a result of the Science Mission Directorate side of NASA. And yeah, we're looking to get an increase of 5 to 6%, keeping up with inflation just about. And within Science Mission Directorate, there's Earth Science, healthy increase for doing climate change relevant research, for example. Planetary science is holding steady with inflation. Got a lot of things going on, Europa Clipper, Mars sample return, seeing a good increase in research and analysis funding, which our professional society has done a lot to advocate for, and actually that's a big win for us in our advocacy, seeing the day-to-day scientists get a lot of research and analysis wins there. But our friends in astrophysics and heliophysics, even frownier smiley face frown emoji, has a cut, and that's not even including inflation. So we got some work to do to increase that top line of the Science Mission Directorate to keep everything healthy, keep all these projects going that we want to keep the discoveries coming with. So when it comes to these different missions that all these different mission directorates, subsets have, I want you to understand that we'll talk about Europa Clipper, we'll talk about JUICE and Mars Sample Return as really large flagship class missions. Those are a few $1 billion each. James Webb Space Telescope is up at the $10 billion level. Whew. Yes. And we have more more nimble, cost-effective missions as well. Medium-class New Frontiers, including New Horizons and Juno, which Southwest Research Institute is the PI institute for, we're proud to say. And smaller Discovery-class missions, there are lots of them. But the ones relevant to us are Lucy, also led by Southwest Research, Lunar Reconnaissance Orbiter. I'm an instrument PI on that mission. We've got a lot of grad students working on that here. And SWIRI is also big on the interstellar mapping and acceleration probe mission in the heliophysics line. So we want to keep that heliophysics line going, make sure this IMAP mission gets launched. And then there are smaller missions still, CubeSats, commercial lunar payload services. Our colleague in Boulder delivered an instrument built by lots of engineers here in town, actually, to one of these commercial providers that are going to land an instrument on the moon and spit out electromagnetic probes to search the soil on the moon. And Tracy here, host of AOT, has led a PRISM proposal for us to go put the next lander on the moon, and we'll wait any day now to see how that goes. So that's a smaller $50 million class payload for us. But yeah, I want to say all of these missions still go through this fundamental propose it, pre-phase A conceptual study, maybe NASA defines it in some sort of study, and then they'll do a more detailed analysis in phase A. Phase B is building prototypes to make sure that what we build will work. Phase C actually builds the hardware, and /D is actually kind of testing it out, putting the solar arrays on, integrating it, and finishing it up and getting it to the launch site. After it launches, we call it phase E, and when it's done, we call it phase F. There's a fly attacking me here. So all these missions, big or small, follow the same sort of management across the board. So when it comes to deciding which missions should fly, we have lots of inputs as scientists working through professional societies, through National Academy surveys, decadal surveys, and other studies and reports. And the decadal survey is really a powerful tool in our advocacy as professional society to say, hey, this isn't just me coming in looking for a quick buck on this mission that is all about me, 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 me. No, this is really a consensus among the community saying, we really need to go to Europa. We really need to go to the moon and all these great places. And we talked a little bit at AOT in the past about the planetary decadal survey. There was an astrophysics one just before that. And in the works right now is the survey for the heliophysics folks, the solar and space physics group. Boom. And I'm super proud to say that Stephen Fuseli, here in the crowd today, is a co-chair of that next survey. It's a very big honor, big role in the community to really say, this is where we need to go as scientists. So that's super cool. All right, so what can I do? Hey, Kurt, man, you got me really jazzed up. I want to help you out, man. This is a list of people in San Antonio. We've got 2 senators, of course, like every state does, Cornyn and Cruz. And I've met with both of those offices, and they are strong supporters. One thing about space is that it's very bipartisan. I love the fact that it is a bipartisan effort. And despite whatever kind of headlines these folks sometimes come up with, Democrat or Republican, it doesn't matter. When you get them all in the room, they're all really excited about what NASA can do and what this space stuff does for the nation. Yeah, cool, woo. And I've met with various folks in all these offices, on the staff level at least, and everyone's really responsive, everyone's really supportive. And yeah, we've got a lot going on in Texas, and the more that we remind these folks that, yeah, we've got a lot going on in Texas, not just with Johnson Space Center and the astronauts, but all the science we do here, the better for us all. So here's where we are with the star there. You can take a look at where you live in town. Take a note of the number that you have if you don't know who your representative is, and go back and make sure you know who your representative is. In a few slides, I'll have some phone numbers for y'all. And yeah, encourage you to reach out and contact these offices. It's super simple. These people are just really excited to talk about space. They're really happy to have their constituents come in and say, hey, space is awesome. And there are other ways you can get involved. One thing that I really like is this planetary.org organization. You get like a newsletter, you read all sorts of fun space stuff that we do here as planetary scientists. And it's the CEO is Bill Nye the Science Guy. And he's done a really good job of making this organization very relevant on Capitol Hill in terms of the advocacy that they do in addition to our professional society. It's a not-for-profit company, just the same, but if you're a member, you also get invited to go with that organization to a Hill visit and walk around on Capitol Hill with Bill Nye there, for example. So that's cool. So I want to say, on more of a side note before I wrap things up, that I'm the local host for a large meeting of planetary scientists coming into town, not just from those of us here in town in San Antonio, but from across the country and across the world, really. There are 2 organizations DPS is the American one. Europlanet Science Congress is the European one, and it's a joint meeting between us here in October. We're going to be at the Marriott River Center Hotel, and we're going to have 3 different public outreach events. The one that's kind of more geared to adult education, if you will, sort of that Neil deGrasse Tyson level of education, is the Sagan Medal Award Lecture. So we'll be filling you in the months ahead on more details about that event. And if you have kids you want to bring out to the Laurie Auditorium on the Trinity campus, we'll have an event there. Any amateur astronomers in the audience, we want to have you out for that as well. So stay tuned. Lastly, here's the Stargazer statue. It's pretty new in town, and I think that's a pretty good representative for AOT here, and a nice note to leave us on. I've got time for questions. Text them up here, and like I promised, here's the phone number. Here's a little spiel for y'all, and thanks for supporting space.
Before we hand this over to questions, I just wanted to remind everybody here, and a lot of people are brand new to Astronomy on Tap, so a lot of the missions that are exploring space that Kurt just talked about and showed are actually missions that are either led out of the Southwest Research Institute here in San Antonio, or we built some of the instruments. So I don't know how many of you knew, let's ask, how many of you knew that instruments were built right here in San Antonio that have been exploring space in the meantime? Go ahead, shout it out. Yeah. Yeah. All right. So, we're going to take a few minutes for questions, and then we're going to go on to our break. So.
Yes, I don't have much time for questions, so you can text me, but I'm probably not going to get to you because we already have some. This first question is, so somebody's understanding is that the typical budgetary cycle is 5 years. And space missions are larger than 5 years. So how do you recover?
Sure. So the budget gets laid out for the next 5 years, but that doesn't mean that there isn't some sort of idea that the budget will continue for 5 years past that. So there will be a chance to, actually I've got the perfect slide for this. So folks will start planning for 2 years ahead of time, basically, at that line item by line item, gritty, detailed budget within NASA, and then go through this process of that iterative, send it to OMB, send it to Congress, have it voted on, and that is a 3-year process. And so they do think a couple steps ahead before they even start what you're seeing on this plot here. But that doesn't mean that with a decadal survey you don't have an idea already of what's going to happen. And once you have a mission that's into this phase CD officially, it's basically as official as it gets, and that just takes 3 or 4 years to get into that phase.
All right, thank you. This next question is, how much has privatization of space launch affected the NASA budget?
It's done wonders in terms of just the sheer numbers of missions that we can launch. Sometimes the cost of the missions had included the launch cost, but then they got taken out. But it really does fall into the overall budget scheme of things in a way that lets us fly more of our missions to more places in the solar system. Yeah.
Very good. All right, and then the last question is, so the most recent decadal selected Uranus as a flagship, is how quickly can that be thrown into the budget and started the process?
Yeah, with the economy and inflation and everything just holding steady, we would need a pretty good sort of 5% increase on top of that to open up a new line of funding for a brand new flagship mission. So in my mind, waiting for Europa Clipper to launch in 2024 is a good time to start funding the next mission to come after Europa Clipper. And that'll take another 6 to 8 years to really get that mission built and launched and on its way to Uranus.
Right, thank you. All right. The St. Kurt Retherford once again, Dr. Kurt Retherford once again.
Thanks, everyone.
While we transition back, I do know that we are on the break. We have a 10-minute break, as usual. Do not crowd the bar. If you need anything, wait staff is coming around. Order from the wait staff in the room. And reminder that we have our merchandise table up here in front for your perusal. And we'll be back in 10 minutes.
What's coming out of this? Check. Check, 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 check. Is it getting any louder over there? Hey. Is it louder? Is that better? Or is that quieter over there? That way? Okay. There's a pan, but it's like opposite to what I was expecting. Okay. Check 1 2 1 2. Is that okay?
We are continuing on. Okay, it's a little quiet. End your conversations now. All right, break is now over, and I will just give it to Caleb so you can learn about astronomy in the news. Thank you.
Well, good evening, everyone, and welcome to another edition of Astronomy in the News. Once again, thank all of you for attending Astronomy on Tap this evening. So, first for the skies of April. If you look up in the sky around 10 o'clock p.m. throughout much of the month, this is the general view of the sky that you will have. All of our wintertime constellations, Orion, Canis Major, all of those are setting toward the west, and the skies of spring are right above us. The constellation of Leo the Lion here, the mane, the head, the chest, the heart, the bright star Regulus of Leo the Lion, and a triangle-shaped back end, and that nice Big Dipper, part of the larger constellation of Ursa Major, the Great Bear, right overhead as well. So, again, that's the general layout of the sky. Now, what's there to see? Well, Mars is still fairly well placed over there toward the western side, but the real show actually starts earlier in the evening. So if you go out around sunset and you look toward the west, especially around the middle part of the month, actually a little early, around April 11th or so, you will see both Venus and Mercury over there toward the west. Venus will be the brightest star you see just above the western horizon, and then Mercury will actually be at the highest point it will be throughout much of the rest of the year. So make sure to see that. It will be a little bit of a trick to see it, but nonetheless it is there. It'll be a rather small star-like object there on the horizon. The Lyrids meteor showers this month, it's not one of the best meteor showers, but it's falling on nice new moon time of year, so you will be able to see many of those meteors pretty well in a nice dark location. That peaks around April 21st, 22nd. And then finally, a deep sky object for you to look for. If you find this very faint upside-down Y-shaped constellation called Cancer the Crab, and take a look at the center of that upside-down Y with a pair of binoculars, you will see this really beautiful field of nice glittery stars, and that is the Beehive Cluster. It's about 600 light years away, so you're looking at it, it's appeared about 600 years ago, and it's somewhere in the neighborhood of about 500 million years old. Now, our own sun's about 4.5 billion years old, so this is a very, very young group of stars, as is the case for most open star clusters, as we call them. So now on to some of the important findings that have been released to the news over the past couple weeks or so. So first off, there actually has been revealed some evidence of active volcanism on the planet Venus. A couple of researchers, Herrick and Hensley, 2023 is the date of the paper release, obviously this year. Go out and look it up if you get the chance. They looked through some old legacy data from the Magellan mission. This was a radar ranging probe that orbited Venus in the late 80s, early 90s. And they actually noticed some regions, particularly these two likely volcanic mountain features, Matmons and Ozamons, where certain features in the surface changed in just a 8-month period of time. And this is actually the first pretty decent evidence that we really have of possible active volcanism on the planet Venus. So very interesting finding there. Now going on to a little farther out, in fact, way, way farther out in space, there's a mission called Gaia, and it's an astronometry mission. And what this mission does is it simply measures the distances and motions to stars in our galaxy. So this image you see here, it looks like a real image of our galaxy around us. It is not. It is a synthetic image. It is actually made by plotting all of those stars that Gaia was able to observe as little points on a plot. And what you see actually looks very much like a real stellar image, but again, you would be mistaken. And within this field, Gaia noticed very interesting motions around a couple of regions, and or at least the researchers analyzing the Gaia data, I should say, and therefore two black holes were discovered in Sidway. And one of these has been the closest black hole revealed to us yet, at about 1,560 light years away. That's actually pretty close compared to many of these findings. So really, really interesting stuff there. And speaking of Gaia, in conjunction with the Hubble Space Telescope, a double quasar has been discovered. And what this actually is two galaxies colliding in the very early universe. This light is from just 3 billion years after the universe began. So pretty early on. Again, consider that our universe is estimated to be about 13.5 billion years old. So very, very, very young light. And nonetheless, a very interesting sight with the Hubble Space Telescope. By the way, this discovery was just announced within the past few days. So going on to some findings with the James Webb Space Telescope, and by the way, there's actually been an awful lot over the past few weeks. I had to be really picky and choosy with my stories here, but this is one that caught my eye most immediately. JWST actually measured the temperature of a rocky exoplanet, so a more terrestrial-like exoplanet, one with a very solid surface, not one of these big gas giant worlds. This one, TRAPPIST-1b, is actually a member of a group of 7 planets orbiting around this particular star. And there had been a number of estimates made of what its surface temperature could be, depending on different ideas of how much atmosphere the planet had, what the surface composition was like. And lo and behold, the measurements with the JWST showed that the TRAPPIST-1b temperature was very close to this latter model here, with a dark surface, no atmosphere, and no redistribution of heat. Now, of course, this is a rather close planetary system, only about 40 light years away. That's about 240 trillion miles away. How many of you are planning on making that journey any day soon? They're going to have to shorten it a lot for me, let's put it that way. And then another interesting Hubble Space Telescope discovery. So, for a long time, it's been known that Saturn has a rather odd ultraviolet emission. It's what's called the Lyman alpha bulge, just above and below the equator of Saturn there. Well, there's been a lot of ideas as to what could be causing this. Bottom line, there is a heating that is taking place. It's energizing hydrogen gas, causing the Lyman alpha to emit from that. That's a bandwidth of hydrogen released radiation there, Lyman alpha to emit from the planet. And what's thought to be happening when putting together the data from HST, Voyager 1 and 2, and especially Cassini's in situ measurements of the system, is that there's material infalling towards Saturn from the rings that is interacting with the gases in the atmosphere collisionally, and that's heating up that atmosphere and causing that Lyman alpha emission. So that was a rather interesting finding, again published just probably about a week and a half ago or so. And then finally, this was yesterday's big news item, or at least one part of this was, the crew has been announced for Artemis 2, the first, the first human return to the lunar space since, of course, 1972 when the Apollo 17 crew went there. This crew will just fly around the moon. They will not land on the lunar surface, but nonetheless, again, very fascinating mission. I encourage you to look up the backgrounds of all of these astronauts. Ray Wiseman, the commander, Victor Glover, the pilot, Christina Koch, Mission Specialist 1, and Jeremy Hansen, Mission Specialist 2. All very interesting backgrounds. It was really an amazing event watching that reveal because they all got to speak themselves about their experiences and what the mission meant to them. So again, really great stuff. 3 of them have flown in space before. The 3 Americans have the Canadian, Jeremy Hansen. This will be his first mission into space. Mid-last month, the spacesuits that will be used for the Artemis 3 mission had been revealed. They are cool looking, but they will not be that color. I know, too bad. Unfortunately, wearing an all-black spacesuit in the intense heat of the sun is probably not a very smart idea. So it will probably be white in color on the outside to reflect away the solar radiation. But nonetheless, we're on the way. It's really happening. We really are going back to the moon with human passengers on board the spacecraft. Finally, just a few things to keep in mind coming up. One, do not forget the solar eclipses that are coming up, the annular eclipse that is taking place just this coming October. Do not forget it. It will be taking place very soon. And then on April 8th of 2024, just a little over a year from now, a total solar eclipse will be visible from the San Antonio area. You do not want to miss it. I saw the one in 2017. I was up in the Missouri area observing that one. Even though it was cloudy, it was still a phenomenal event. You do not want to miss this. And then finally, we do have an observing coming up at the UTSA Observatory on April 7th at the end of this week on Friday evening. I'm not holding out a lot of hope for the weather, but keep it on your calendars just in case, all right? And then finally, Juice is launching. And actually, I think our next talk will discuss a little bit about that. Yes, Juice is launching. It will be launching on Thursday of next week. Tune into that if you get the chance. And again, I'll let our next speaker have the say on all the details of that. So, all right, and that is Astronomy News. Once again, thank you very much.
Thank you very much, Caleb. I have the opportunity of introducing our next speaker. So, Ange is a research scientist at Southwest Research Institute. Her research focuses on the development of space plasma instruments and data analysis of Jupiter's largest moon, Ganymede. After studying in France and Germany for her undergrad, Ange completed her PhD in the north of Sweden, where she built the instrument for the JUICE mission that is the subject of this talk. She came to the Southwest Research Institute to continue developing instruments for space exploration missions. And finally, her favorite part of research is understanding the way instruments affect the science we can do based on their measurements. And of course, we have the drinking word, which is...
Spacecraft. Spacecraft.
Spacecraft.
Okay. Can you hear me clearly? Okay, so I'm going to talk about the JUICE mission to Jupiter's icy moons. But before that, I want to talk about why we are going to Jupiter, why it's important to send spacecraft to Jupiter. Okay. So this is an image where you can see all the planets in the solar system. Their sizes are to scale, but not their distances. I just wanted to use that image to put Jupiter's size into perspective. So Jupiter is the largest planet in the solar system, and it's much bigger than Earth. In fact, if it had been a bit bigger, it could have become a star like the Sun. And because Jupiter is so big, that creates a lot of... It's related to all the things that are amazing about the Jovian system. And because it's so big and bright, we can see it easily in the night sky, and we can also do ground-based observations of it and deduce a lot of science from that. And so we've been able to do that for a long time, but we realized the Jovian system is so complicated that we need to send actual spacecraft to it. So that's what we did. First, we started with just a spacecraft that flew by Jupiter on their way to the outer solar system. So we had Pioneer, Voyager, and Ulysses that were going to the outer solar system, and then Cassini was going to Saturn, and New Horizons was going to Pluto, and as they flew by Jupiter, they took some measurements. And then finally, 20 years ago, we got a dedicated mission to Jupiter called Galileo. So Galileo was actually in orbit around Jupiter, and returned a lot of measurements that completely changed the way we view the Jovian system, in particular the moons of Jupiter. And recently, 6 years ago, the Juno spacecraft arrived at Jupiter. Juno is actually was managed by SWRI here in San Antonio and carries several instruments built by SWRI by people in this room. And Juno is still orbiting Jupiter and returning a lot of interesting data. But JUICE is going to be the first mission to go specifically to the Jovian system to study the icy moons of Jupiter. So I'm going to talk a little bit about the moons. So Jupiter is a big ball of gas. And because it's really big, it trapped a lot of objects around it, hundreds of objects. About 95 confirmed moons are orbiting Jupiter. And 4 of them are really big. They're actually bigger than our moon, and one of them, Ganymede, this one is actually bigger than the planet Mercury. So if you look at those pictures, you can see already that those moons are very different. And that's related to their proximity to Jupiter. So because Jupiter is so big and those moons are also big, there's very strong tidal forces that create internal sources of heat inside the moons. So very close to Jupiter, we have Io, which is very much heated by the interaction with Jupiter. And as a result, it's covered with volcanoes, hundreds of volcanoes that are erupting, ejecting about 1 ton of sulfur dioxide into the space around Jupiter. Next up, we have Europa, which is she's usually, I guess there are a lot of Europa fans because Europa is often thought to be one of the best places in the solar system to look for life, because we know there's a subsurface ocean under it, and the reason that there can be liquid water at Europa and also at Ganymede and at Callisto is because of the internal heating provided by the tidal forces from Jupiter. So Europa has a very smooth surface, and that tells us that the surface is very young, because otherwise it would be covered with craters like the moon. The moon's surface is very old, but comparatively, Europa is very young, like millions of years instead of billions. Ganymede and Callisto do look covered with craters, so we know their surface is a bit older. But since the Galileo mission, we also know that they do harbor subsurface oceans underneath. So already from this picture, we can tell that there's good reasons to send spacecraft to Jupiter and study those moons. But there's also something that is less talked about because it's invisible, and it's one very a special thing about Jupiter. That's the magnetosphere. So to talk about Jupiter's magnetosphere, I first want to talk about Earth's magnetosphere. So in this picture, this artist's view, you have the solar wind on one side, represented in orange, which is permeating the interplanetary space and heating, well, it would hit the Earth if not for this blue bubble around the Earth that is protecting it from the solar wind. And this blue bubble is basically what we call a magnetosphere. And that's created by the fact that Earth has its own magnetic field. So the interaction between the magnetic field and the solar wind creates a magnetosphere, this bubble. So that happens at almost all bodies in the solar system, all planets, and that happens at Jupiter. But of course, Jupiter is giant, and so it has a giant magnetosphere, much bigger than Earth's magnetosphere. In fact, if you could see Jupiter's magnetosphere in the night sky, it would be as big as the moon. That's how big it is. Viewed from the front, it would be as big as the moon. If you could see its tail, it actually extends all the way to Saturn sometimes, to the orbit of Saturn. So Jupiter has an immense magnetosphere, and this artist's view is from inside Jupiter's magnetosphere. Whoops. So you can see that the moons are orbiting Jupiter inside its magnetosphere, and that creates a lot of weird interactions between Jupiter and the moons, especially because of the presence of Io. So I said before that Io is covered with volcanoes, and those volcanoes eject a lot of sulfur dioxide into Jupiter's magnetosphere. And when that material gets ionized, so the atoms lose an electron, they become ions, and suddenly they start feeding the magnetic field of Jupiter. And because the magnetic field rotates at the same speed as Jupiter itself in 10 hours, which is faster than all the moons around Jupiter, the result is that there is a plasma, a torus of plasma, which is orbiting Jupiter at 10 hours and taking over the moons from behind. And every time it hits the moons, it interacts with them in the same way that the solar wind interacts with Earth to create a magnetosphere. Not all the moons have magnetic fields, so we don't have magnetospheres at all Jupiter's moons, but Ganymede does have its own magnetic field. So what happens is you have a magnetosphere inside a magnetosphere. And that's a unique situation in the solar system. And that's the kind of thing that JUICE wants to study. So the JUICE mission, it stands for Jupiter Icy Moons Explorer, and it's the first Jupiter mission to be led by ESA. ESA is the European Space Agency. You may not have heard of it, but it's the equivalent of NASA for Europe. And it's basically a group of many European countries that contribute a small amount of their taxpayers' money to fund space missions, like JUICE. So, as I said before, JUICE is going to focus on Jupiter's icy moons, and that's the first spacecraft to do that. It's not going to just fly by the moons like other spacecraft. It's going to end up orbiting Ganymede, and it's going to make, in total, 35 flybys of the moon, which is, I think, more than the number of moon flybys combined so far. And JUICE is going to launch on April 13th, which is next Thursday. You'll see that date coming up again. So a few questions that JUICE is going to try to answer. Why is Ganymede so unique? So Ganymede is the largest moon of Jupiter, and because of its magnetic field and subsurface ocean, there's a lot of stuff that we don't understand about Ganymede and we want to study. What are ocean worlds like? Well, all the icy moons have subsurface oceans underneath, but the way we discovered them is through magnetometer measurements, which, I mean, it's good enough to detect them, but we can't tell much about it without making detailed in situ measurements with other instruments. So what we do is we make models and try to compare them with data that we have, but when we have data from JUICE, we're going to have a lot more to make models with. Then how has Jupiter's complex environment shaped its moon? So as I mentioned before, Jupiter is interacting with its moons. Or maybe I didn't mention that the interaction between Jupiter's moons and the magnetosphere creates current systems. So that means there are particles going from the moons to Jupiter itself, and that creates aurora at the poles of Jupiter. So that's one thing that JUICE is going to try to understand. What a typical gas giant planet form, how they form, how does it work? So JUICE is going to focus on the icy moons, but also it's going to spend some time studying Jupiter, and it's going to add to the large set of data that we already have on Jupiter. That helps us get a bit closer to the answer to this question. And then could there be or ever have been life in the in the Jupiter system? So, as I mentioned before, Europa is considered the best place for life in the solar system. That's because at Europa there's a lot of water. There's also a lot of water on Ganymede, much more than Europa actually. But at Europa the ocean is quite close to the surface, and it's also over the rocky shell of Europa, which means it can get minerals it can exchange minerals with the rocks. And we believe that it's more likely that life could have developed on Europa than at other icy moons. Because at Ganymede, for example, the ocean is trapped between two layers of ices. So, okay, so the JUICE timeline. Now we are here, launcher preparations at the European spaceport in French Guiana. JUICE just got mated with the spacecraft. JUICE got mated with the rocket. So it's sitting on the rocket waiting for launch, and it's going to launch next Thursday, April 13th. But unfortunately, we're not going to be able to just launch JUICE at Jupiter and take data in like 2 months. We're going to have to wait 8 years. And in order to accelerate and make the trip as short as possible, we're going to need to fly by some other planets, like we're gonna come back to Earth, and then go to Venus, and then Earth again, and finally in 2031, we're gonna arrive at Jupiter and start orbiting Jupiter and making flybys of the moons. JUICE is gonna make 35 flybys of the moons, 2 of Europa, 21 of Callisto, the rest of Ganymede, and eventually it will go into orbit around Ganymede. So it will be the first spacecraft to orbit an icy moon. And eventually, so I hope the mission gets extended beyond 2034. But whatever happens, the end of mission plan is to crash JUICE onto Ganymede. So we're gonna get really nice pictures of Ganymede at some point. So to do all the science that I've been talking about, we're gonna need to put some instruments on JUICE. And they can basically be separated into 3 packages. The remote sensing package contains 3 cameras, Janus, Magis, and UVS. UVS was built here at Swarry. Like all the other UVSs roaming around the solar system. And SWI is gonna look at radio waves. Then the geophysical package, so that's going to be more aimed at the icy moons. Those kinds of instruments have not really flown before to the Jovian system. So we have a GALA, the laser altimeter. It's going to shine a laser onto the surface of the icy moons and look at the reflection, at how the surface affects the light that is reflected. And RIME is kind of going to do the same with radio waves. And hopefully, RIME, the ice penetrating radar, is going to inform us about the thickness of the icy shells and the thickness of the oceans. So it's going to be really interesting to have this instrument around icy moons. Then there's also the radio science package, and then we have the in situ package, the last of the 3 package, containing the JMAG magnetometer, the RPWI plasma wave instrument that's going to measure plasma waves that are created when electrons and ions interact with magnetic fields. And then the PEP instrument. So PEP is counted as 1 instrument, but it's actually 6 instruments. I know this one well because I worked on one of them during my PhD in Sweden. This one, it's called JNA. And so this particle package is put on JUICE specifically to study Jupiter's magnetosphere and its interaction with the icy moons. And I think it's going to be the first time that so many instruments for plasma are flown to Jupiter. So I'm really excited to see the results that they're going to return. So PEP was managed by Sweden, but many countries participated to the different instruments, and 2 of them were built in the US. So I wanted to show you a picture of how the instruments look like when they're on the spacecraft. So this is a picture of the side of JUICE. It's the side with the most instruments, and it's really hard to tell what is an instrument on this picture if you don't know where they are. And I don't know where all of them are, but I know where my instrument is. It's here. And I know that these are also from the PEP package, the package that's going to measure particles. I know that UVS is probably sitting in this corner, which we can't see it. I think that's the GALA laser altimeter, and that may be the Janus camera, I'm not sure. And that's an antenna. I actually tried to include a recent picture of the UVS instrument since it was built here, but I modified my talk too late and sent the email too late. It didn't get through. So sorry about that. So that picture, I think, I'm not sure because I couldn't find the source, but I think it was taken some time ago in Germany. Because the spacecraft was, so all the instruments were built in different countries in Europe, and then they were assembled in Germany, and then the spacecraft was moved to Toulouse, France, where they performed the final assembly. And then it was put into a big box, and the big box was put into a big plane, an Antonov plane. And it was shipped to French Guiana, which is a French territory, but it's not in France. So I put a map of South America to show you where French Guiana is. It's this little blue country above Brazil. Conveniently, French Guiana is located close to the equator, so we can launch spacecraft from French Guiana for cheaper than any location in Europe. So that's where the spacecraft is now. And you can see again the particle environment package here, like my instrument, and an antenna here and some cameras here. Oh, maybe UVS is on this corner. Okay, so that's my last slide. JUICE is almost ready to launch. This is a picture of the rocket, the lower part of the rocket on which JUICE is going to sit. It is sitting right now. This is when it was moved to meet JUICE. And this is when JUICE was integrated onto the rocket. And very recently, I think, I don't know when it happened, but the pictures were released this morning. They put the fairing, so the top of the rocket that covers the spacecraft, they lowered it down to, they put it on top of JUICE very recently. And so now the rocket is closed. JUICE is, no one's going to see it again. And yeah, it's almost ready to launch. It's going to launch next Thursday on April 13th. Local time here, okay, that's confusing. 9:15 is when it will launch in Kourou in local time in French Guiana. And for you, it's going to be 7:15. So I hope a lot of people are going to be up and remember that there's an exciting launch about to happen. And you can watch it on the ESA website. Thank you.
All right, thank you, Angel. That was very, very cool. Yes, I wooed for Europa, but all of the Galilean satellites are amazing. So, shout out to EO, Europa, Ganymede, and Callisto. All right, questions. Be sure to text the number because I did not get as much this time in the off during the speak. So text that number. Is the magnetic field of Jupiter made in the same way as Earth, the driving process?
Basically, yes. Internal dynamo of the core.
Okay.
Yeah. So.
What will you be doing between launch and Jupiter insertion of the spacecraft?
I don't know, living my life.
Huh?
On JUICE, I won't be doing much. I mean, it's going to take some data when it goes by the each of the planets, Venus and the 3 Earth flybys. And it's also going to be going through a lot of testing. So I'm going to follow that. But yeah, I'm going to be waiting for the data from Jupiter.
Very cool. Here we go. They're flowing in. I heard juice. What is the picture? Oh yes, that cute picture on the side of the spacecraft. Where did that come from? Right there. That photo of Jupiter, and I'm assuming that's Ganymede.
This thing?
Yes.
I think there was a context in Europe where children could submit drawings of a drawing for the JUICE mission to be put on the fairing, and this was drawn, I think, by a girl in Ukraine.
Very nice. Wow.
She won the contest, and then when the war broke out, I heard she got taken in by the manager of the mission.
Oh, that's very nice. That's such an adorable photo. Somebody call NASA. Tell them. Like Kurt was, call your senator. Tell them to put photos on our rocket. What are you most excited about in your field? What are you most excited about in your field of study? What excites you the most?
I don't know. I guess right now Ganymede. So I'm working on data from Ganymede from the Juno spacecraft.
Woo! I must, the general comment, the woos tonight could use some work, everyone. I know that some of you it's your first time, but others, you've been here before. You gotta, it's multitasking. It's a skill.
Yeah, so the Galileo spacecraft flew by Jupiter, flew by the icy moons of Jupiter quite a bit, and we got data from then, which is 20 years old. But 2 years ago, the Juno mission flew by Ganymede again, just once, but we got some data which is very exciting, and that also doesn't match the data from Galileo, so it's a challenge to understand. And since I also worked on an instrument that's going to measure stuff coming from the surface of Ganymede, I'm very interested in Ganymede itself.
Very cool. All right, and the last question for this session is what got you started and involved in instrumentation? What was it just opportunity, or was it?
So I studied physics originally, and when I was studying, I was always frustrated by how disconnected we were from reality, learning about physics in the classroom. And then one day I attended a talk on one of the French instruments that is on the Mars Science Laboratory mission. It's a laser camera that was built in France and also in the US. And I discovered the world of space missions and instruments, and I got interested, I think, attracted to it because of the human side of it. And then when I entered in that team, they gave me subjects that basically showed me how much the way the instruments measure stuff anywhere in space, they affect the science that we do, and sometimes we don't realize it. And it's really important to understand your instrument if you want to understand your science. That's what got me interested.
Very cool. Very interesting. All right, let's thank our speaker once again. Take this from you. All right, that brings us to the. Oh, you want this, or yeah? All right, and that brings us to near the end. But Tracy has some.
Yeah, just a few quick announcements. So first, thank you all for coming. How awesome were these two talks tonight?
Woo!
In just a minute, we're going to explain the trivia rules, but before we do that, I just want to say big thanks to Blue Star. Thank you, Joey, in the back. Give a round of applause to Blue Star and the servers. And a couple other announcements. So Caleb talked a little bit about the upcoming eclipses, as did Kurt. And so there are solar eclipses coming. October 14th is a Saturday. That's going to be the annular eclipse. There are a bunch of events being planned, both by all of the astronomy clubs, SALSA, the San Antonio Astronomical Association, UTSA, SWIRI, the Whitty, Museum, Scobie Education Center. They're all going to be hosting events. So be on the lookout for those. Information will be slowly trickling out soon. If you're interested in being a volunteer to get trained on how to then give presentations on eclipses, we're going to be announcing opportunities for that as well. So you can actually go out and be the one talking at some of these events after being trained with us. So be on the lookout for more information. We'll share that next time as well. And I think that's, and we have solar eclipse glasses, actually. So we have tons of them. So if you want to get a pair, many of them have been very nicely donated by Robert Reeves. Thank you very much, Robert. And some of them have been donated by UTSA, and a lot of them are just generally donated by NASA. So thank you, all of you who have donated glasses. And if you don't have a pair yet and you want to come up and get some, come on up and get some. And we're going to start now explaining the trivia. So thank you all.
Alrighty, so trivia tonight, as usual, it's not lit. Sam, is there a second slide or no? Okay, I'm going to have to explain everything, so I need all of your ears because we have no text on the slide. If you're participating in trivia, we're going to come around with answer sheets and writing utensils should you need them, okay? The rules are you're not allowed to use your cell phones because, duh, come on. And something new this time, 5 people to a team maximum. We're cutting it off at 5. No booing. Think about it. Just think about it. And then, of course, if you are a physics student, you may participate, but you may not win. But we'll put you in a separate pool against the other physics students. So traditionally, we'll have the grad students compete against the undergrad students for bragging rights. But maybe we'll have a prize this time for you all. It'll be my love. No. But everybody, if you need, as we come around, if we skip your table, just let us know. 5-minute break while we disseminate the sheets, and we'll be back with trivia. Thank you. And come up for glasses if you want them. We're not walking around with those. You got to come up. for these questions. They are multiple choice. Put the letter down, just the letter. Okay, thank you. Question 1. Before NASA's founding in 1958, the U.S. government studied flight innovation through which committee? Your choices are A, the National Aeronautics Committee for Aviation, B, the National Advisory Committee for Aeronautics, or D, the National Science Committee for Space Research. Which one of these predates NASA? Let me see.
Okay, question 2. What percentage of the U.S. federal budget is allocated toward NASA as of 2020? Is it A, 0.03%, B, 0.31%, C, 2.12%, or D, 8.21%? We care about our significant figures. Please don't get it wrong. Bonus. So we ask that you write a letter, but next to it, if you can give us a number for what was the percentage at the height of the space race. So give it as a percentage, and the closest answer is awarded credit.
This is a memory recall question, so if you get it wrong, tisk, tisk. We will have our usual bonus. This is a double bonus.
We've had some experience with more tiebreakers, so we're trying to add them in.
Too many of y'all get the same answers, and it's like, okay.
Y'all are just too good. You're just too good.
Is everybody good on this? Okie dokie. Question 3, how long will it take JUICE to reach Jupiter after it launch? Another memory recall. A, 2 weeks, B, 6 months, C, 1 year, D, 4 years, or E, 8 years. How long will it take JUICE to reach Jupiter?
All right. Question 4. What animal could be seen clinging to the space shuttle fuel tank during the STS-119 launch in 2009? Was it A, a bat, B, a squirrel, C, a seagull, D, a grizzly bear, or E, a lizard?
What an image.
What an image. Just a grizzly bear straddling the fuel tank. Anybody seen Cocaine Bear?
Alrighty, move on to question 5. Yes, yes, okay. Question 5. There's a starman waiting in the sky. He'd like to come and meet us, but he thinks he'd blank. That's a David Bowie song. If you don't know it, then, open Spotify and a good song.
No,
but not now.
Not now.
Not now.
Not now. We're watching.
Is it have to say goodbye, waste our time, blow our minds, or nearly die. Finish the song lyrics by David Bowie, the late David Bowie.
Like the movie?
Good?
Question 6. In what chronological order did the following spacecraft fly by Jupiter?
Woo!
We'll give you some time on this one. Is it A, Pioneer 11, Voyager 1, Cassini, New Horizons? And now the other ones are just going to be some kind of spin on those 4 spacecraft.
A, B, C, D. In order. Typo. Use your brain. Use your
Context
brain.
clues.
Brain.
The answer, I'm not going to say what the answer is, but context clues. All right, what is the order of these spacecraft? Honestly, I'm going to let you all read it because that's just a lot of words. I'm not going to say the same 4 spacecrafts over and over in a different order. But remember, we want chronological order, and it goes A, B, C, D. Did I hear that's not chronological? It's alphabetical, but we want the answer in chronological.
Yes. So
I hear you.
You have to. You have to put the right one. I know they all say A, but don't put A if it's not A, or don't put A if it's not that top line. If it's any of the non-top lines, you got to put the corresponding letter. We're making you think.
We've all taken multiple choice tests before. We know how it goes.
All right. Despite all the confusion, is everybody good with this question? Can we move on? All right. That's
Bonus.
it for all our questions. So as usual, we enter our bonus round. Our bonus round today is a spicy one because we're going to ask you to name the 5 scientists who have won 2 Nobel Prizes. Hint, the list contains 4 men and 1 woman.
And however many you can name, that counts.
I'll give you another hint. One of them is painfully obvious. Wait. Yeah, I guess that is a pun. Painfully obvious. One is painfully obvious, and the other is spicy too. I said spicy before, so we'll keep that one. There's 2, yeah. Since this is the last question, as you all wrap up, please, as you finish up, raise your trivia in the air. We'll come around and collect them, and we'll take another little break as we tally. Make sure that as you close out your tabs, you tip your wait staff very well. They've done a great job tonight, and we'll start compiling answers and announce winners.
Just want to make sure we got everybody's trivia sheet and our pens, please. Cool, thank you.
Students, what was your team name?
Wondergrads.
Any other students? What was your team name? Okay. You didn't submit one? The graduate students cried tonight.
We cry every night.
Okie dokie. All right, everyone. Where's my clicker? We have the winners for tonight's trivia. But first, as always, we do our answers. We tell you the answers because, yes. That one's all the time, though. That's. All right. So question 1, which was about the name of NASA before it was NASA. So the acronym was NACA, which would have, if you knew that would brought you between options A or C. And the answer was C, the National Advisory Committee for Aeronautics. the giveaway, I mean, the partial giveaway of that one is NASA, the first A is aeronautics. National
today.
Aeronautics and Space Administration. So they didn't change too much. And also, back here, this hangar has NACA on it.
Wow, I didn't even know that. Dang. Snuck it right by you, huh?
Rare.
Wow. Okay, question 2. 0.31% of the federal budget. That was a memory recall. That one was said out loud, nonetheless. Oh, and then the height of the space race, 4.41%. More than 10 times more.
All right, question 3, which was about... Question 3, oh God, what was question 3?
Let's find out.
We'll find out. Yes, how long will it take Juice to reach Jupiter? It's 8 years. 8 years for Juice to get to Jupiter. Fun fact, we all heard that Juice goes up next week. It's a lot of fun. You'll be able to watch it on live streams. Europa Clipper is supposed to launch next October, so October of 2024. It will reach Jupiter before Juice because it's got a better rocket. So, poor Ariane 5. It's doing its best. It's doing its best. All right, question 4.
Question 4. I don't remember what it was.
Oh,
It was a bat. It was not Cocaine Bear. Yes, there was a bat
there's
hanging
a
on the
close-up
side.
image right there of the bat clinging for dear life.
Apparently, the story goes that the bat's wing was broken and thus couldn't fly away because they have sirens that go off before every launch to scare away the wildlife and all the avian mammals. And apparently, yes, as I said, the bird was a little flightless at the time, ironically.
All right, the next question was the David Bowie lyrics. There's a starman waiting in the sky. And the finish, but he thinks he'd blow our minds. See. He'd like to come and meet. Yes, that's right. That's right.
I figure it was half and half. Either you really, really knew it or you really, really did not know it. I was one of the ones that did not know it.
Okay, the last one was our little confusing one with everything was A, but not really A, with all the missions. And the answer...
Psych! Threw a little diversion at you.
So, yes, Pioneer 11, Voyager 1, Cassini, and New Horizons. Each one building on the past one, and all of them have great data that have influenced our knowledge of Jupiter and its moons. So, all right. So the bonus was about 5 scientists that have won the Nobel Prize more than once. It's a very prestigious award to begin with. So imagine winning it twice. And the 5th one actually just won the 2nd one last year. So it was 4 for a long time, and it recently became 5. And those scientists are Fred Sanger, both in chemistry, Linus Pauling in chemistry and a Peace Prize, John Bardeen, both in physics, Carl Barry Sharpless, that's the one that just won it last year, both in chemistry, and Marie Curie, the physics and chemistry.
Now,
Marie
if you were
Curie
wondering,
is, huh?
if you were wondering,
Yeah. Marie Curie was the spicy one. Radioactivity is spicy. And then Fred Sanger, painfully obvious, that is Mr. Penicillin right there. Huh?
the pun goes,
Insulin. No, not penicillin. Insulin. Wait, no, penicillin. Which one was penicillin?
none
I
of
thought there
them.
was no, insulin.
All right.
Yes.
We threw you a curveball.
But yes, but I mean, insulin. Yeah, I get them confused. I don't need either, so that's why. So that's our answers for tonight. We have 3 winners. No ties this time because our trivia master did a good job of preventing ties. So we'll start honorable mention, our student competition. We had multiple student crowds in the group, and the winner of that one was the undergrads. Congrats, undergrads. UTSA undergrads represent. Yes. Birds up, birds up. You do realize if the grad students participated, you would have lost, yeah? No, they didn't. Sorry. All right. Our real prizes. So 3rd place, we have a lovely LRO poster, a Europa sticker, 2 NASA stickers. There should be 2. And a Celestron Purell/Germex bottle.
Keep your hands clean.
You can use it on your lens to keep it clean if you have a telescope. I was waiting for that. The winner of 3rd place is Team Alien Life Forms. Come on up and get your prize. Congratulations. Alrighty, in 2nd place, which prizes today of, once again, those 2 fabulous stickers, Europa and NASA, and a tumbler that is also Celestron themed. So this one you can drink. Don't drink the other one. No, don't drink that. But you can drink out of this one. It is Celestron, right? Yes, it is. Okay. Thanks again to Robert Reeves for those. We have straight arrows. The winner of 2nd place. Congratulations. All right, last but not least, our 1st place prize tonight features a book by Neil deGrasse Tyson titled Astrophysics for People in a Hurry. Our 2 fabulous stickers, NASA and Europa, and yes, there's an and. Open it. A beautiful JWST image. One of the deepest images taken. Very pretty print. Beautiful. The winner of 1st place in tonight's trivia are the Juicy Boys. I appreciate the name. That was a good trivia name, topical. Very good. Congratulations. Yes. And the stickers. Or you have NASA?
We got NASA. This is awesome. Thanks, guys.
Here, one more.
Love it. Appreciate it. Thank you.
All right, that is trivia for tonight, everyone. Thank you for staying with us through trivia, and thank you for attending our AOT tonight. Our next AOT will be, yes, thank you. Our next AOT will be on the 1st Wednesday of May, which will be May 3rd. Be sure, if you are tabbing out right now, to tip your wait staff very generously. They've done a great job tonight. Thank you again to the Blue Star Brewery and the Southwest Research Institute for their support. And thank you all. And we'll see you again next month. Come enjoy some merchandise if you'd like at the front.